Good afternoon, everyone.
I'm a civil engineer. Little known facts about the airport. We are a statewide system. We operate and maintain 15 airports across all the islands. We have airports on Oahu, on Kauai, on Maui, Lanai, Molokai, and Hawaii. So we are self-sufficient. So we don't get any taxpayer or general funds from the state. All of our revenues that we have, we generate through our leases with the airlines, with our stakeholders, the tenants, concessionaires. We also, have parking revenues, and also like when you buy food and beverage from our concessions. So all those revenues is what we use to operate and maintain the airports. And about 75% of the revenues is used for operations and maintenance. The other 25% is used to help pay for our debt services. So the funding for capital improvement projects that we're going to be touring today, primarily comes from revenue bonds that we sell, and also from federal grants that we get from the Federal Aviation Administration. So being that we do receive federal funding, we are under the jurisdiction of the FAA. So to begin, all of our capital projects are identified in a master plan document. So this master plan document, it forecasts our passenger growth maybe for about 20 years. Sometimes it can go longer, to 30 years. And based on that anticipated passenger growth, we also look at the capacity of our terminal facilities, our airfield, our ground transportation, cargo, and also the utility infrastructure. Because we need to be able to make sure that what we build, we do have the support from infrastructure to focus. So once we master plan, and all of our projects, needs to have an environmental document, whether it's an environmental assessment or environmental impact statement. This is to document that the project that we're doing will not have a significant impact to the environment. So this document looks at everything you can think of, water quality, air quality, noise, light, visual impact, historical buildings, archaeological sites. Anything you can think of, this document will look at to make sure that there's no significant impacts to the environment.
Wildlife too.
Yeah, fish and wildlife.
Is that for one project?
It's for one project in this master plan, or sometimes we have several projects grouped together in a program.
Okay.
Then we'll do one document for the entire program.
But that document right there is for just one of your projects.
This document is what is used for the project that we're going to do.
Jeez, that's a lot of paper.
Yes, it is. So
Well, it's been a while since I've seen that spiral too.
yeah, so once this document is approved, which needs to get approved again, because we're under the jurisdiction of FAA, it needs to get approved by FAA before we can even proceed with the project.
So is most of the traffic through the airport passenger, or do you also have freight?
Primarily, it's passenger, but we do have cargo. Our cargo is across the airfield on what we call a south ramp. We're on the north ramp. The north ramp is primarily for passengers. So right now we have about pre-COVID, we're averaging about maybe close to 38 million annual passengers. That's both deplaning and inplaning. Because as a resident, if you leave, you have to come back. So the country is twice. And for tourists, they come and then they leave. So the country is twice. So total, it's about 38 million annual passengers.
And so are there other airports on Oahu that are under your system, or is it just HNL?
No, so we're a statewide system. So all the airports across the entire state.
All of them, okay.
Yeah, come comes under our.
I see. Oh,
So, engineers, they're problem solvers. So we're always going to be asked to solve problems or challenges, whether it's a new project, even in your everyday life, if you want to build a house, you have many different solutions of building a house. So you as an engineer will need to come out with, look at all these different options to find out what's the best solution, that's going to be right for you and your customers. You're not going to be 100% right. There's no right or wrong answer. You're not going to satisfy everyone. There's always going to be people who don't like what you did. But again, as long as you have the documentation as to why you did it that way, then that's all people can ask. So part of the challenges being at the airport is that the aviation industry is always changing, and it causes a lot of challenges on the existing facilities that we have. The aircraft are coming bigger and heavier, so that also puts a strain on our pavement strength. That we also have to keep monitoring whether or not the pavement is adequate to handle the additional load. Just for example, I don't know if you guys heard of it. It's a double-decker aircraft.
Is that the Japanese one?
It's a Japanese aircraft that you go into the aircraft and then there's a stairs to aircraft. You need a loading bridge that goes up to the upper level. That aircraft alone, when it's fully loaded, is over 1 million pounds. That's something that ANA, Japanese carrier, told us that they were going to start flying. So we have to go in and make sure our pavement could handle that 1 million pounds load, as well as modify some of the gates to add this third loading bridge. So one of the biggest challenges is this building right here. This was called, I think you guys might be too young, but this is called the Inter-Island Terminal. We had the United, the other terminal where United and Delta and American fly out. That was called the Overseas Terminal. So this building, that I was part of, and that's why I'm kind of, I wouldn't say passionate about, but I guess it's one of the things that really upsets me every time I hear something. This building was designed for inter-island travel. If you remember, there was Aloha Airlines and Hawaiian Airlines, and they used to be where all trans-Pacific passengers was flying to Honolulu, and then if you wanted to go to a neighbor island, you would fly out of this building here. So even Hawaii, their trans-Pacific passengers was flying out from the overseas terminal. But I'm not exactly sure when, but they consolidated their operations to handle everybody from this building. So again, this building was not designed to handle passengers going to the mainland. It was designed to handle passengers going to a neighbor island. So now when Hawaii consolidated the operations here, obviously the ticket lobby was not designed to accommodate that. A trans-Pacific flight has about 350 passengers. The inter-island flight has about 120 passengers. So when you add the inter-island passengers plus the trans-Pacific passengers, the ticket lobby was not designed to handle that volume of passengers. Likewise, the checkpoints, the baggage claim, was not designed. So that's why you always see the congestion out there. And that's why I say, it's kind of my pet peeve that whenever I hear that there's so much congestion out there. Again, it was not because this building was not designed to handle that volume of passengers. Similarly, the airport system was designed, like I said, Honolulu was the hub and spokes. So all passengers had to come to Honolulu. And then to go out to a neighbor island, they would fly from here to go to a neighbor island. Now, again, with the changes in the aviation industry and how airlines operate, you have all these direct flights, United, Delta, American flying directly to the neighbor island airports. So again, the neighbor island airports was not designed to accommodate 350 passengers arriving at the same time. So again, same problems, ticket lobby, checkpoint, hold rooms, baggage claim, it's all undersized. So that's part of the challenges of being an engineer. You're always going to have these things thrown at you, even after the project is done, where now you have to try and do your best to come up with solutions. The challenges for an airport is that you're usually landlocked or surrounded by residential or industrial areas. So we really don't have room to expand. And we just try to come up with the best solution to make our existing facilities work. So I know we have short time, so I don't want to spend too much time talking, but we can go to the project. Both projects, what's becoming an engineering standard right now is sustainable design. And it is called LEED, L-E-E-D. So it's the leadership in energy and environmental design. And it's trying to promote sustainable design. So looking at the sustainable sites, looking at your water efficiency use, your electrical usage, using natural resources, looking at indoor air quality, materials that do not have their strong VOC, what we call volatile organic compounds. And like when you used to paint, you can smell that paint fumes. Part of this LEED is to eliminate using materials like that. So both projects that we're going to be looking at, one is the Malca concourse. That's about a 250,000 square foot facility. It's going to accommodate 11 aircraft gates. It's about $270 million, and it's expected to be completed in August of this year. And the other project is our consolidated rent-a-car facility. So that's a 5-level structure. It's going to be housing all the rent-a-car companies into one building. Just like what you guys see on the mainland. So it doesn't matter who you're renting a car from, Alamo, Budget, Hertz. You just catch one bus, it'll take you to one building. And then once you get to the building, then you can go find Alamo or Hertz. So that one is about $360 million, and we're anticipated to have it completed by December of this year. So again, being an engineer, especially at the airports, you're going to be have the opportunity on very high visible projects that again, will have a tremendous impact, to the community, both the residents and the tourists.
So have you always been in the aviation side of civil engineering, or did you start in a different area?
In my private sector, I was in the transportation.
Okay.
And then when I came to the airports,
I see. That's a natural sort of transition. Yeah.
Right. Are there any questions?
Yeah, any questions from any of the students there? Maybe they're thinking about their questions. They'll tell y'all later.
How did you fund the two projects? Is it like airport revenues, or is it like FAA?
So the Malca concourse was funded by revenue bonds. Our consolidated rent-a-car facility, we had this special fee. It's called customer facility charge, or CFC. So it's when so that's going over, and then when you're coming back over, there's another part looking at it. So a round trip, you would be paying $9 a round trip, and that money is what we call the customer facility charge, and that money was used to pay for our consolidated rent-a-car facility. We also have a rent-a-car facility in Kahului that was also being funded by the same customer facility charge.
So are you keeping the old rental car facilities? Are you replacing them for?
No, the new So we have to temporarily relocate the existing operation into the parking structure.
Yeah. And then, so with all the rights, did you all have to change the pickup and drop area at all?
We did provide space on our curbside
Okay.
to accommodate the ride sharing. So again, that's why there's all these challenges that will always come up that will need to be solved, whether it's going to be done by the engineering or could be done by operations. But it's never a done moment.
Well, the traffic's only going to increase here, right? Because that's revenue for this, the island, I suppose. So.
It's already starting to increase, and forecast is for the summer.
Yeah.
We're going to be exceeding the pre-COVID levels.
Oh wow. Okay. It looks like you have a busy future ahead of you. No shortage of problems, though.
Right.
Any other questions? I mean, anything that feels too.
What grade is everybody?
Yeah, we didn't.
My name is Noelle, and I'm going to be a junior.
My name is Megan, and I'm going to be a junior. I'm
Justin, and I'm gonna be a senior. Well, like I'm gonna be a senior. I'm Kenneth, and I'm gonna be a senior.
So do you guys all have aspirations to be an engineer? Are you guys still thinking about it?
We're trying to convince them to this chat. So we talked a lot about like designing roads for different cars, and we'll talk about the geometries. And so it's similar to what we experienced with the different aircrafts, right? And so I guess there's no way to kind of forecast if there's going to be like a bigger plane or a heavier one. So kind of just have to make an engineer's judgment. Oh, okay, sorry.
I was going to ask, what's the typical process you go through from when you
So being that we first have to request our funding from the legislature. Even though we don't get general funds from the state, we still need to get their approval to release the funds. So once we get the authorization of the funds, then we start the planning process. Because like I said, there's so many different ways of designing the project. Yeah, we want to get all the stakeholder involvement to make sure that what you're designing will meet the operations and functional needs of the users. And then once we have that concept then we can start the design and then go into construction. So I would say a typical project, assuming everything runs smooth, will take about 3 to 4 years.
So I don't know if you realize, but we're streaming to CNMI and American Samoa, so they actually have some questions. And so Catherine Kim from American Samoa asked, she wants to ask, which aspect of civil engineering encouraged you to continue in the engineering field? Like, I guess, what was it about civil engineering that motivates you?
Okay, well, I think, I guess the reason why I asked what grade are you guys in, because I'm sure you guys all took physics. And I took physics, I think, in 10th grade. And, when they're teaching us about forces, I think that really interested me to become a civil engineer. And, that physics class, I think, you guys can apply it to real world situations. Even like the carnival ride, the one that goes around in a circle.
Like a carousel?
No, I guess
roller coaster.
The one that goes fast around in a circle. What happens? Where do you guys like to sit? Like for me, I would like to sit on the inside.
Let's tilt a world.
Right, because when it spins around fast, what you guys learn in physics called centrifugal force, forces go outward. Right, so if I sit on the inside, I'm the one squishing everybody who's sitting on the outside. Right, so
Okay.
and it's the same thing with like when you design roads, as you go around, same thing, centrifugal force. So you go around a curve, the car is going to tend to slide outward, right? And that's why when we design roads, they have what they call super elevation, where the road is not flat, it's kind of dank to help your car to stay on the road. You know, so again, another pet peeve of mine is whenever I hear on the radio that an overturned car happened, it's because why? They were speeding around the turn. Right, so the roads are designed to handle a maximum speed limit. And you see all these big trucks that are just speeding by and they go around the turn fast. Again, in physics, the center of gravity for a big truck is higher. So if they go around faster speeding, it's easier for them to tip over. You know, so physics and that forces kind of interested me in getting into engineering because, you know, whether or not you call me a nerd or what, but, you know, that's what got me interested.
I would say also because technology changes every 3 to 4 years, your design has to somehow adjust to that. And that's why I was interested in civil engineering. So there's something changing every 3 to 4 years, either a new vehicle or more bikers or.
Yeah, and just the other week, you know, I was on a presentation and, you know, Mokulele Airlines, I don't know if you guys heard about that. You know, they're the single engine propeller Cessna planes. They have about 9 seats. You know, they're talking about flying electric aircraft. You know, they're looking at about like a, you know, 45-year time period to start flying electric aircraft. And being Hawaii, being the distance from island to island is not that great. You know, it's the perfect route for electric aircraft because, you know, the miles that they can travel on a single charge, you know, is not that great. The challenge for us is now being able to provide the electrical infrastructure, you know, at the terminal where the aircraft is going to be gated in order to be able to support that initiative.
So they're really going to move forward with that electric aircraft for intra-island.
You know, it sounded like they were serious about it. Yeah.
I have a question.
Yes.
Are there currently any aircraft or makers that are going into the electric route? Like, I mean, not like Boeing or Airbus, but like smaller that you know of.
Not that I know of. I know some manufacturers was looking to biofuel. Yeah, but not electric.
Okay.
Any other questions?
Okay, well, let me
think
go
we're
put
good,
this
yeah.
away.
Go ahead.
I'll get my hard hat and stuff. I can meet you guys out front by the elevator.
Okay.
Okay.
Sounds good.